In this video, we're going to create a custom Braille embossing cylinder from start to finish. Then download the 3D printable STL file for both the embossing cylinder and the counter cylinder. Both of these parts are needed for the 3D printed Braille embosser, which impresses a readable Braille dot into cardstock. By the end of this video, you'll have 2 printable STL files. In the next section, I'll cover 3D printer setting recommendations. First, we'll start at the Braille Customizer app in a web browser. So here's the starting page. On the right side, you've got your text input area, language selection, card thickness, and plate selection, which is where most of the work happens. On the left is a 3D preview. It'll update as soon as you press the Generate button at the bottom of the menu. You can find the accessibility controls at the top. You press this button to switch between dark mode, light mode, and high contrast mode. You press this button to increase font size or decrease font size. The 3D preview panel has its own brightness and contrast controls. Before you type anything, the most important decision is figuring out what to put on the embossing cylinder. For this Braille embosser, it allows about 13 Braille characters per line. That means you won't be able to translate everything from a standard business card. The Braille Authority of North America, BANA, has published a prioritized list of recommendations for translating a business card into Braille for exactly this situation. Translating your name should be top priority, and then at least one contact method. Next would then be job title, then mailing address, then fax number. For a more detailed explanation, please click the Help button in the top right corner, or use the link in the info panel. It covers what to include and why, and a couple of examples, which is all backed by BANA's recommendations. I'll paste all of my business card information into this Braille Customizer text area. Right away, there's a warning telling me the text exceeds the available space. That's normal and happens to pretty much everyone who pastes their full business card information. So let's edit it down based on the BANA priority list. My organization is already in my email address, so I can remove the organization line. My job title isn't essential, so I'll drop that too. Before moving on to the next step, here are a few settings worth knowing. The placement mode option is set to auto placement by default. In this mode, when translating your text to Braille, the program automatically handles wrapping your text across the available lines. Translating capitalized letters is disabled by default. In Braille, to capitalize a letter, you place a capital indicator character just before the letter you'd like to capitalize. So each capitalized letter will take 2 character spaces instead of just 1. So disabling capitalized letters will save quite a bit of space. If a person happened to have a name that might be confused with a common word, this could be a good reason to capitalize the letter. For example, if somebody happened to have the name Otter spelt like the animal, it could be helpful to capitalize the O in Otter to be less confusing. This program uses Liblouis. In any translation situation, accuracy is critical, and that's why I choose to use Liblouis, which is an open source Braille translation library, and is widely regarded as one of the most reputable, freely available translation tools. That being said, it's always a good idea to cross-check your results with another online Braille translator program or a Braille specialist. Moving on to the next section. The input language is set to English UEB uncontracted by default, which is also what BANA recommends. Thanks to Liblouis, there are over 50 language input options available if you need them. It's important to keep in mind this isn't translating between other languages, just between the input language and Braille. For example, if you'd like to translate French into Braille, you'd first need to type in the information in French and make sure that the language option is selected to French. Okay, next section. Card thickness controls the embossing depth. Right now it's set to 0.4 millimeters, which is standard for most business cards. There is a 0.3 option available if your card is slightly thinner. Whichever one you choose, please keep a note of it. Both the embossing cylinder and the counter cylinder must be generated at the same thickness. Mismatching the setting between 2 cylinders can lead to the embossing cylinder's dots being damaged. Next step, make sure the embossing plate option is selected in the Select Plate to Generate section. Then go ahead and press the Generate STL button. The generating process can take anywhere from a couple of seconds to a couple of minutes, depending on what kind of device you are using. Once it is fully generated, it'll appear on the left in the 3D preview panel. If you're using a mouse and keyboard, you can click on the cylinder to drag, rotate, scroll, and zoom, or you can use touchscreen controls to do the same thing. If you've generated your cylinder, you'll be able to see the braille dots on the cylinder surface. Here in my example, this is the indicator shape area. Here, you'll see the indicator letters B, J, and W, which is just the first letter of each of the first 4 words. These indicator letters is to have a built-in labeling system for non-Braille readers. That way, if you print more than one Braille cylinder, you have a quick way to identify them apart. Now let's download the embossing cylinder we just created. If it's successfully generated, then the Generate STL button should change to say Download STL. We'll click it again, and it'll start the download process. The embossing cylinder file should automatically be named after the first word that was typed into the translation. Before we're done, we need to generate and download the counter cylinder to complete the pair. The counter cylinder has all the Braille dots activated. It was designed this way so that it could be used with any custom version of Braille that you might generate. So as long as the card thickness setting is the same, you'll only need to download and print one counter cylinder for as many custom cylinders as you would like. To generate it, scroll down to the setting, plate selection, and select Universal Counterplate. Then press the Generate STL button again. Then press the Download STL button again. If you're going to experiment with different thickness settings, I recommend you add that information to the file name that you download. For example, counter cylinder 0.4 millimeters, so that way you don't have to second guess the size later. For advanced control, there's an Expert Mode button at the bottom of the page. This section lets you control dot shapes, dot spacing, and many other things. You can find more information on this section in the help guide. Now that we've generated and downloaded both of our STL files, let's move on to 3D printer slicer settings. First, import both STL files into whatever 3D printing slicer software you'll be using. I'm going to be using Bambu Studio. In my experience, the seam painting feature makes a significant difference in Braille dot quality. Most automatic seam placement settings will try to hide the seam in a visually inconspicuous spot. Common places are corners, edges, or inside recesses. It's totally fine for normal prints, but it becomes a big problem in our Braille embossing process. If a seam is placed either on a Braille dot or within the recess of a Braille dot, it can significantly change the embossing dimensions. So I recommend using the seam painting tool. So that way you can control the seams and place them away from all of the dots. I've set the seam painting brush to vertical mode and increased the size to 4. I've chosen to paint over the indicator letters and triangles. This now tells the slicer to put the seams in this area only. Don't forget to also do the counter cylinder. I'm using a Bambu X1C 3D printer, and the following settings of what worked best for me. I start with Bambu Studio's high quality preset, but I've still had pretty good results for anything smaller than 0.2 millimeters. Here are a few changes I made from the default setting. First, I've changed the wall generator from Classic to Arachne. Arachne handles the small details of the Braille dots a little more consistently. The biggest difference I've noticed is a slightly more accurate recessed Braille dot. Next, I reduced all default speeds to about half. So initial layer to 40, infill to 75, outer wall to 50, inner wall to 75, small perimeters to 40, and halved all the accelerations as well. For my printer, I didn't need any supports and I didn't need a brim. These are just my starting points, so if you're still getting clean prints at a higher speed, you should just keep your settings. But if you're seeing Braille dot quality issues, I'd recommend slowing down the 3D print as a starting point. With these settings, using basic PLA on a Bambu X1C, I can 3D print both cylinders in about 3 hours. This Braille embosser was designed to maximize efficiency. Once the outer housing mechanism is 3D printed, and a counter cylinder is printed, it's much easier to update information or add information since you'll only need to 3D print a new custom embossing cylinder, which only takes about an hour and a half on my type of machine. In a group environment like an office or a classroom, each person would only need to 3D print their individual custom embossing cylinder, which only takes an hour and a half and a small amount of 3D filament. And that's it.